The sounding rockets, launched quite routinely from this barren shore, vary in size from the 6-foot HASP to the 72-foot Scout. They can send hundreds of pounds of instrumentation as much as 3,500 miles into space. Since the end of World War II, these workhorses have sent back valuable information about the composition and characteristics of our upper atmosphere. From heights above the ionosphere, they have also been able to return information about stars and galaxies.
Welcome back to Kerbal Space Program. Grizzly here, and we're going to start off this year's program with the second flight of the Skylift on January 5th. I put it back together and, of course, put a few decorations on it, make it look proper. I did figure out how to finally drop that probe without detaching the pylon from the wing by putting an extra decoupler system onto the pylon. And you can see the probe immediately opens the chute as long as I'm down below 5,000 meters. So then I spent some time gathering up scientific data over the water, the deep water, and headed in to drop the second probe back in the tropics like I attempted the first time, and I missed the target. So you see I'm going up to the decoupler. You can see it's just underneath the pylon once I make sure all the scientific instruments are on. And from there I can just launch it down, and there goes the chute. Turns out it's not as practical from a game perspective as I would like, because it takes a lot of funds and a lot of time to rebuild those probes every time. Use the chute for a quick landing. We'll move on to picking up the probes, one from the water and one from the jungles. Be nice when Kerbal 2 comes out and we'll have some plains, we'll have some jungle trees and stuff. Speaking of interesting terrain, this flight took out the X1 and went out to land out in the desert and into the mountains. The landing went well. I just had an unfortunate experience with the Kraken. And if you've ever played KSP, you know the Krakens when physics go suddenly awry unexpectedly. So I was taking ground readings and took my pilot out so she could do the crew report observations and EVA observations. First thing I noticed is I couldn't get back into the spacecraft or the plane. The hatch is too high. Yes, maybe a ladder would have been a good idea. So I was trying to figure out some other way of getting up there, and it wasn't working. And then that happened. My hair hit the plane, and the plane started taking off down the hill. And the race was on. Not one of my better moments, as the aircraft continued to pick up speed going downhill and quickly outpaced my running speed. So I had to recover the pilot separately and then use the tracking station to get the plane. Everything survived though. So this is Claw 15, and Claw 15 being launched from Wallops. The video we were watching was about Wallops Air Force Base on the Chesapeake. And this whole mission, what the big thing is different is there is another Aerobee engine above this one, and it's in a one-stage boat tail. It's basically a fairing that doesn't deploy. So once the fuel runs out on this, the entire nose cone section doesn't have any mass in it other than fuel for the Aerobee. And the idea of this mission was to see just how high I could go. My target was 300 kilometers. You can see I also put just a little bit of a spin into the top fin for stability purposes. Rotating the nose section keeps it more or less in a straight line. You see there the entire Chesapeake Bay. Upper right of the screen would be Washington, D.C. And we get going pretty fast. Looking up the coast, you can make out the coastline of New Jersey, and I'm pointing out right now with the mouse that was Long Island. Long Island right now is underneath the rocket, and the Cape would be just to the right. So yeah, we well exceeded 300 kilometers. In fact, I made it all the way up to 400 kilometers, which was unexpected. I guess the angle is just right. So here I'm taking a look at the trajectory and noticing how well I did. So a complete success in this flight. Now coming down, the downside was I knew I was going to be coming down very fast. And I was concerned whether the rocket would be able to re-enter. As it turned out, those spinning wings help stabilize it, but they take most of the brunt and blow off the spacecraft. But that boat tail acts as a nice air scoop, and the rocket quickly decelerates. And with parachute deployment, mission is a complete success. The only thing I really lost was those fins. Okay, X2, 55 kilometers. This was the rebuild of the X2 because I had lost the last one, had some damage due to the flat spin issue. So I was partly trying to figure out why that happened. So I knew I had to get to 55 kilometers for the mission success, but that wasn't going to be too hard. But I wanted to see if I could recreate it. My suspicion was that it was just a lack of aerodynamic lift and control once I got to that altitude. So pretty standard flight profile, going up at a little over 50-degree inclination, 3 engines, full burn. And at this point I start to nose down because I'm hitting the target altitude. We're at 45 and we're going to hit 55 pretty quick. Now you notice the wobble starting, and it's starting to wobble towards the left. And my suspicion is that the rockets are slightly off center. Of course, I eyeball them putting them in. And that just might be enough that I got that little bit of wobble. Now with the engines off, there's of course no aerodynamic control on those surfaces. So my X3 plane, I'm going to have to put in some kind of control attitude jets to keep strain level. Now, having introduced the same set of circumstances I had in the last flight, I wanted to see if I could recover by relighting the engines. And you can see I'm chasing, at this point, I'm chasing the direction of travel marker on the scope below. I'm just trying to keep the nose pointed towards it until I can get a bite of air. But hitting the engines actually worsens the whole effect. Now of only 20 kilometers of altitude, I get into a true flat spin. So really, there's only one way of preventing this, and that is to maintain sufficient forward velocity with attitude jets and built into the wings in order to keep it level. Deploying the parachute helped to stabilize it, but I knew that the parachutes wouldn't really stop the rotation until they went to full deployment, which is pretty soon, so I dropped my gear. And now that the chutes have really bit in, we get stable. The other thing I found out on this flight is that my parachute deployment needed to be adjusted. When I adjusted the X2 to put in the third engine, I should have adjusted the forward chute for the center of mass. But survived. So that was a close call, but all turned out well. This flight, I decided to do the entire flight from inside the cockpit, which is an interesting experience. So this one's just slightly higher. It's a 60-kilometer mission. This one's on June 2nd, so I had to wait the 3 months for the reward for the mission to build back up. That happens over time. See, my surface speed about 520 meters per second at this point, going pretty quick. And the altimeter gauge on to the right of the gyroscope is accurate in thousands and hundreds of feet. Or I should say meters. So I easily achieved this mission, and if you watch that gyroscope, you see I'm pulling the nose down. My actual direction of travel is the circle, and the wing shape is the direction of my nose and wings. So I'm just chasing it down as we go through the curvature. And by doing this, I maintain control throughout the flight. You can see White Sands Range below in that bright white area, and there's the air base. Now I was really nervous about this flight because I didn't want to pop outside the cockpit for the duration of the flight. I wanted to stay in the whole time, but I had to keep track of where that airfield was at all times. Now I'm on final approach, having circled around a couple times, just getting the speed and altitude down. and I was going really slow. We're at 94 meters per second right here. And you can see when I touched down, I was barely moving. Matter of fact, it just barely made the runway. Now this one's interesting. Wait for it. First booster, and then boom. Put on 3 more solid rocket boosters onto the first stage engine to get the speed up. The trick with this one is this one's pretty heavy, and I need to make sure I had enough forward velocity to keep the nose up. So I also put the spin on. You also notice that all the way up on the nose section, it is a little bit wider. It kind of tapers out and tapers in. That was a deliberate design choice. And what I did is I split it up. The bottom third of that is actually fuel for the third Aerojet AJ-10, and the top 2/3 is the cargo payload. This one again is a U.S. Air Force mission request. And the class testing, I had to get to 140 kilometers minimum. It had 335 kilograms of weight in that nose section, which is pretty heavy. And I had to get 170 kilometers downrange, which isn't terribly far, but it was a respectable distance with that much weight on board. So you can see I'm designating right there where the nose section was, where the cargo was. So this worked pretty much just like the 400 kilometer Claw 15, except for I expanded that nose section so I have both fuel and the cargo in that section. Now the last AJ-10 is lit inside the boat tail. I'm arming the parachute, and I had forgotten to turn on the science experiments. I gotta really remember that because there's telemetry analysis and supersonic flight I can get data on still. Now once I get the payload downrange far enough and high enough, then the mission's success. I don't have to recover it, but I always like to try to recover this top nose section. As you see, this one is launching out in California, Vandenberg Air Force Base, and away from Los Angeles. There's San Francisco in that little bay area. And I do indeed hit my objective for both the altitude and the range goal, downrange goal, at about the same time. So a very successful mission. Now if you're wondering what's going on down in Texas this whole time, I have the rocket launch pad being developed, as well as a more advanced controllable rocket, the Black Bear, and that one's taken a while. It's over a year for all that development to take place. I do have new solid rocket boosters also just about finished at the point of this mission, based on the Nike design. And you see this time the top section is balanced enough that it kind of floats down. It is actually at 13 kilometers in altitude above the cloud tops, and it's going a very stately rate, just about turboprop speed. Eventually, it does nose down and it starts to accelerate, but at that point, we're already down to parachute altitude, 5 kilometers. Right about now. So we safely recovered that, and this is the bane of my existence. These flights, I hate them. I really hate them. So the idea of these is to maintain a set speed at a set altitude for a duration of 3 minutes. This took me 5 tries. Of course, every time I either didn't get the approach right, or I ran out of fuel just before the end, or wasn't paying attention, got too high, too low, or suddenly lost an engine and lost speed. All those things happen in successive flights. This is the one that succeeded. It was the 5th attempt, so I had to go through a training cycle, replace the engines, renovate the plane. What I learned is at this point, when I get up to the right altitude, I turn the one engine off, and it's the one that's in the center line the most. And that is so if one of the other engines suddenly fails, I can turn it back on. That's why I have the mouse over the reactivate key. And in doing so, I can maintain the speed through the end. That was how I lost one of the flights where I wasn't able to sustain the speed. A sudden engine loss. So they do give you a bit of a cushion. You got about 100 kilometers, or I should say, 100 meters per second variance between 400 and 500, and you can go between 13 kilometers and 14 kilometers in altitude. But to watch on the top your altitude, watch on the bottom your speed, watch your fuel, and keep everything in balance for 3 minutes is really nerve-wracking. And this is the hardest one because it's at a fairly low altitude and it's much harder to control. I did clip about half this flight out. It is literally a full 3 minutes when you hit the parameters. At this point, mission's complete. And it would have been great to end the video here. Big success, everybody's happy, but that's not going to happen because I was so excited I actually jumped out of my chair at this point. And then I realized, I still have to land this thing. I started dipping down the altitude because I realized I already overflew the airbase. I'm going to have to come back around, and I decided I was going to pull it back up once I got on lower, but I was not watching my airspeed well enough. Still going very rapidly, and I kind of pull up a little bit too hard. Now this is okay, nice gentle tug, but then I hit a little bit too hard and there goes my wings. Now you notice it's still flying, but you still have the tail sections and they still have my steering control, which I just test right here just to see how much control I got. You also have the tail, which is acting as the wing surface, as well as those black sections where the wheels are located. Those are technically wings, and they do have aerodynamic lift. So I actually have a rather surprising amount of control. And for a brief moment, I think about trying to land this as is on the grass. But I do realize I have one of my favorite pilots on board, has the most experience, and I do not want to lose her. And I have no idea how the parachutes would work without the wings, because they're maybe completely unbalanced and flip it up on end. So I decided to hit the emergency eject system for the first time. So I wait to get down in a decent altitude, pull the nose up, and pop. And you see the parachute just behind the cockpit section. So when that thing shoots off, the parachute automatically deploys. And the other parachutes deploy on the main frame. You can see it does come down tail first, but it does survive landing. So after this mission, I was able to recover the nose section and the wreckage, they call it, of the main body, and I was able to rebuild it from the nose section back. But the pilot obviously survives. The mission is a success. I don't have to do it again. But this is going to take us quite a bit of time to repair and rebuild. This mission was in, what was it? July 8th. But I was not able to get any more missions done in the current year. I do have Claw 17 and Claw 18 ready to go, but they aren't going to happen until January. So we'll catch up with them in the following year, 1957. Till then, this is Grizzly signing off.
Ủa, số booster đây này, ủa à, đời số sao em phải cái gì đó rồi.